Let's calculate effective annual yield. And I know what you're thinking. How am I supposed to calculate it if I don't know what it is? Well, there we go. Effective yield is also sometimes known as the effective interest rate. So banks are required to state their interest this way for easy comparison. So to compare from one to the other. It can also be converted to a percentage called the annual percentage yield. So if you see APY and you're like, what is that? Well, that's what this is. It's the effective interest rate, not to be confused with APR. So the annual percentage yield takes into the account compounding. So compounding interest is considered here. When we talk about the annual percentage rate, that does not take into account any compounding. So it might actually underrepresent what is happening. Now, that's not bad if we're talking about saving money. I'm all about you giving me more than I thought. But if we're talking about loans, an annual percentage rate could underestimate what you're going to owe. So how do we calculate effective annual yield? Well, first we assume that P is 1. Remember that P is principal, the amount we borrow. And you might say, well, I'm probably never going to borrow $1. Well, yes, that's true, but this will kind of help the calculations be more simple. So you assume P is 1. You calculate the final amount after 1 year. Again, keep it simple, using compound interest formula. So recall the compound interest formula is A, right? The ending amount equals principal times 1 plus R over N raised to the N times T power. So we make P1, we make T1, makes the formula a whole lot simpler. Now, once we have that amount, we can calculate the effective annual yield. Sometimes the effective annual yield is also shown as R with a subscript of EFF, like the rate effective, okay? So sometimes you might see it like that. And in decimal form, we'll want to change it to a percent by multiplying by 100. So the rate in its effective form is found by taking the ending amount minus the principal divided by the principal. Now again, for our example, P is 1. So this is the same as taking A minus 1 all over 1. Well, if you take A minus 1 over 1, that's just the same as A minus 1. So we're going to take the ending amount, subtract 1, and that's going to give us our effective annual rate. Once again, we're going to want to multiply by 100 to turn that into a percent. Let's do an example and see what this looks like. So you are considering an account that earns 2.5% interest compounded quarterly. What is the annual percentage yield, right? What is the effective rate? So again, think this through. We're going to assume that P is 1, T is 1. We know that R is 0.025. We're compounding quarterly, so N is 4. So remember, step 1, assume P is 1, and use the compound interest formula for 1 year. So we're going to have the ending amount equals principal of 1 plus our rate, 0.025 over 4, raised to the 4 times 1 power. Now, 4 times 1, right? My exponent is just 4. When I multiply anything by 1, it's just 1. So I get A equals 1 times 1 plus 0.025 over 4 raised to the 4th power. Okay, so when I do all of this, multiply all that, I get an ending amount of 1.025235. Remember, after we do all of that, we're going to subtract 1. So I get 0.025235. And this goes on and on and on and on, but that's fine. To get this into a percent, I'm going to multiply by 100. So 0.025235 times 100 gives me 2.52%, and that would be my APY. I just rounded to the nearest hundredth of a percent. So you can see here, my APR, this would be our APR up here, is 2.5, and my APY is 2.52, slightly higher. Again, if I'm putting money in, I'm not mad that they're going to give me more. If this is a loan, then it's going to cost me a little more. So there you go. Effective annual yield.